Last class we discussed what does an algorithm mean? What is the computational model we use for analysis of algorithms? That is RAM model of computation. And what does asymptotic analysis of an algorithm mean? Five different asymptotic notations: big O, big omega, theta, little o, and little omega. So we recall what's the definition of order of growth. So what's the definition of order of growth? So given total number of operations performed in an algorithm, that is loosely speaking running time of algorithm, we drop all lower order terms as well as constant coefficients of highest order term. Whatever remains, that we call it as order of growth or rate of growth. For example, in this case, what is highest order term? 7n square is highest order term. So hence we drop this 8n and 9. Then in 7n square, what are the constant coefficients here? 7 is constant coefficient. So remaining is n square. This we call it as order of growth or rate of growth. Rate of growth. Similarly, in this case, order of growth or rate of growth is 2 power n. 2 power n. Okay. So now in order to solve a problem, if you have two different algorithms, which algorithm is better? Which algorithm is better? Whichever algorithm's order of growth is lower, that algorithm is better. For example, in this case, we have two algorithms. This algorithm A has n square order of growth. Algorithm B has 2 power n order of growth. Hence, algorithm A is very much better or efficient than algorithm B. Algorithm B. So these are here different orders of growth here. 7 n cube. In case of example 1, it is n cube. We drop lower order terms as well as constant coefficients of highest order term. Whatever remains is n cube. Here also same thing. 1 by 2 into n square plus 1 by 2 into n. This n square remains. It is this. Similarly, here also this entire thing will go. So finally 3 power n remains. 3 power n remains. So that's what we learned yesterday. So now, what are?
Is it started? I'm not able to listen any audio.
So what are? Can you hear me? One of you, please respond.
Sir, we can hear you.
Okay, thank you. F of n and g of n are two monotonically increasing functions. Okay, what is big O of g of n? What is big O of g of n? What is big O of g of n? It is set of all functions, say f of n, such that order of growth of f of n is less than or equal to order of growth of g of n. G of n. For example, what is big O of n cube? 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 It is set of all functions whose order of growth is either equal to n cube or smaller than n cube. Give me a function whose order in n, whose order of growth is smaller than n cube.
Square.
Yeah, n square. Thank you very much, madam. Okay. Any other function?
N log n.
N log n, 2n square, n log n, n cube, n into n plus 1 into 2n plus 2. Is that correct? 4n cube plus 5n square plus 6n minus 20. Something like this. Is it finite set or infinite set?
Infinite.
Infinite. Okay, next. What is big omega of g of n? What is big omega of g of n?
Set of f of n.
It is set of all functions such that order of growth of f of n is greater than or equal
Greater than
to
or equal
order
to.
of growth of g of n. G of n. Okay. So please tell me what is big omega of n cube? Big omega of n cube. The n cube is part of it or not?
Yes.
N power 4.
For 4.
N
2
power
power
5.
n.
Yes, sir. 2 power n.
N factorial. N power n. 3n cube minus 4n plus 6. 4n cube. N log n plus 3 log n minus 5. Is it finite set or infinite set?
Infinite set.
Infinite. Okay. Similarly, tell me what is theta of g of n? Theta of g of n. It is also set of all functions f of n such that order of growth of f of n is same as order of growth of g of n. Order of growth of g of n. So what is theta of n cube? Theta of n cube. Theta of n cube. It is theta of n cube. N cube. Is that correct? It is correct. Sigma I equal to 1 to n I square. Sigma I equal to 1 to n I square. What is sigma I equal to 1 to n I square?
N square. Up
So
to
it is I equal to 1
2n
means 1 square. I equal to 2 means 2 square. And this one, it is n square. It is sum of squares of first n natural numbers. What is the formula? What is the formula?
N plus 1
N.
What's the formula for sum of squares of first n natural numbers?
n into n plus 1 into 2n plus 1 by 6.
N into n plus 1 into 2n plus 1 by 6. Is that correct? So this is same as if we simplify 1 by 6 into n square plus n into 2n plus 1. So it is same as 1 by 6 into 2n cube plus 3n square plus n. Is that correct? Is that correct? 1 by 6 into, okay. So now what is order of growth of this? What is the order of growth of this? This we can write it as
N cube.
1 by 3 into n cube plus 1 by 2 into n square plus 1 by 6 into n. Okay. So now what is order of growth of this?
N cube.
We drop all lower order terms as well as constant coefficient of this. Whatever remains, that is n cube. Hence its order of growth is n cube. Is that okay? Is that correct? Okay. So now, can you give me any other function which is part of this? Any other function which is part of this? Is this correct? 8 power log n base 2. 8 power log n base 2.
Yes, sir, correct.
Because this also, what is 8 power log n base 2?
Cube.
Cube.
It is same as 8, n and 8 we can interchange. So finally it is also n cube, no? Same order of growth. Can you give any other function which is part of this? Okay. Any other function which is part of this? Okay, no, okay, we'll see with some other examples. What is little o of g of n? It is set of all functions f of n such that order of growth of f of n is strictly lower than order of growth of g of n. Okay, so now what is little o of n cube? What is little o of n cube? What is little o of n cube?
N for f of n such that
What is little o
order
of
of
n
growth
cube?
of f of n is strictly less.
n square, sir.
Strictly less than n square. That is n square. Is this correct?
N
N power 2.99. Is this correct?
Yes.
n log n
N log n.
log
Even
n
we can give combinations also. No, we can give combinations also. 7 into n power n root n, n square
sir.
root n, n square root n plus 20 n log n minus 5. Is that correct? So like this we can give. Okay. Next. What is little omega of g of n? It is set of all functions f of n such that order of growth of f of n is strictly greater than order of growth of g of n. G of n. So example, what is little omega of n cube? What is little omega of n cube? What is little omega of n cube?
Power 4.
It should be strictly higher. N power 4, n power 3.0001, n cube log n, n cube log n, 7n, n power 3.1 plus 6n square minus 6n minus 20. Like this we can give, no? Like this we can give. So simply 30 we can give, 40. Is this correct? Oh, n power 30, n power 40. Okay, n power 40. Next, n factorial, 2 power n, 3 power n, like this. Now, is it clear with the notations? All 5 it is 5 notations. So now we are going to solve some problems based on this asymptotic notations. If you have any doubt on order of growth and definitions of informal definitions of this asymptotic notations, you please ask me. Because this you should understand. Without that, it's difficult to solve problems. That's why I have repeated this. Is there any doubt at this up to this? Okay, let us go to some. Okay. Now, if any two real numbers are given, A and B, is it possible to write it as either A less than or equal to B or A greater than or equal to B? A and B are real numbers. Is it possible to write it as A less than or equal to B or A greater than or equal to B? Any two real numbers.
Yes, sir.
One condition out of these two must be always true, no? One condition out of these two must be always true. Is that correct?
Yes, sir. Yes, sir.
Yes. Any two numbers that should be true. Either this should be true. If this is false, this should be true. This should be. Okay. Now, for example, we are given two functions, say positive functions. F of n is say n square G of n is n square plus sin n. N square plus sin n. Here, is it possible to write these functions analogous to this a less than or equal to b, analogous to this? What is that we have? What is that we have? Analogous to this, what is that we have? A less than or equal to b. In asymptotic notations, what is that we have? Order of growth of f of n is less than or equal to order of growth of g of n. This is nothing but which notation?
Big O notation.
Big O notation. Similar to this, what is that we have?
Big omega.
Okay, big omega. That means now the question is, if two functions f of n and g of n are given, is it always true that either f of n should be big O of g of n, or f of n should be big omega of g of n? If we are given two real numbers, we know that either a less than or equal to b is true. If that is false, definitely a greater than or equal to b will be true. Greater than or equal to b true. Similarly, if we are given two positive functions, f1 and g of n, is it always true that either f of n is big O of g of n is true, or if that is not true, f of n is big omega of g of n is true? For example,
Yes,
f
I
of
think.
n if I take as n cube and g of n as n square, what is that we can write? We can write f of n as big omega of g of n
Omega of G.
in this case. For example, if f of n is n square plus 3 n plus 4 and g of n is n cube, g of n is n cube, then what is that we can write? F of n is
Big O.
big O of g of n. That means any two functions are given like this. Is it? But whatever two examples we have taken, it is satisfying the condition or not? But let us try for this example, third example. F of n is n square, g of n is n power 2 plus sin n. 2 plus sin n. What is range of sine function? What is range of sine function?
-1 to 1.
Minus 1 to plus 1.
1 to
Minus
plus
1
1.
to plus 1. So n power 2, when it is minus 1, what is the value we get there? When the range
N.
is minus 1, what is the value we get here?
N.
N square. N power 2 minus 1, it is n square. 2 minus 1,
N.
which is same as n.
N.
If it is plus 1, what is the value we get?
N cube.
N cube. So that means g of n value varies from n to n cube. G of n value varies from n to n cube. Is that correct?
Yes, sir.
Okay.
Yes, sir.
So now, similar to example 1 and example 2, in third case, is it possible to write either f of n is big O of g of n or f of n is big omega of g of n? That is our question now. That is our question now. That is our question now. Is it possible to write n square equal to big O of n power 2 plus sin n? Is this true? Is this true or not?
Yes,
Yes,
for
sir.
certain case, if value of n is depends on the value of sin n.
That's finally answer is true or false?
Yeah, we can write. Yeah.
It's false, sir. False.
It is false. Why? Because if this sin n value becomes -1, it is only we are saying that
Yeah, it is
x
n.
square is big O of n. That means it is false. It is false. So that means there is no guarantee that always n square is big O of n power n square plus sin n. Is that okay? Similarly, is it possible to write it as n square is big O of big omega of n square is big omega of n power 2 plus sin n 2 plus sin n 2 plus sin n. Is that true?
No.
No. When does it become false? If sin n is plus 1, minus 1 it is true. Minus 1 it is true. When sin n value becomes plus 1, this overall it becomes n squared is big omega of n cube. Big omega of n cube. We know that it is false. We know that that is false. So from this, what is clear? For these two functions, we are neither this is true, nor this is true, not this is true. So that means what does it mean? What does it mean? What does it mean? Unlike two real numbers for which either a less than or equal to b is true or a greater than or equal to b is true, here we cannot say that if f of n and g of n are positive functions, either f of n is big O of g of n is true. If that is not true, automatically we cannot conclude that f of n is big omega of g of n is true. Is that okay? Is that okay? Is that correct? Is there any doubt at this point? Is there any doubt? Okay. Okay. If there are no,
sir.
let us try to solve
Could you
this.
please repeat that, sir?
Okay. For any two real numbers a and b, either a greater than or equal to b is true, or a less than or equal to b is true. Always. Correct now? For any two real numbers, okay, no, a greater than or equal to b is true, or a less than or equal to b is true. But what is that we have observed is, if f of n and g of n are two positive functions, then we cannot give guarantee that f of n is big O of g of n if it is not true, or f of n is big omega of g of n. Okay, no. Okay, no. Is that okay? If f of n and g of n are positive functions, there is no guarantee that, okay, no guarantee that it holds. Is that okay? Is there any doubt? The example
Okay,
is
sir. Clear, sir.
okay. Now let us see. Okay, now you have to answer. What about the first one? Is that true or not? We are given two functions. One is n cube, the other one is n power 2 plus sin n. N power 2 plus sin n. Okay, first tell me which one has higher order of growth, n cube and n power 2 plus sin n. What are its order of growths? N cubed it is fixed. N power 2 plus sin n, it can go from n power 2 minus 1 to n power 2 plus 1.
2 plus 1.
So that is n to n cube. It can go from n to n cube. Now you tell me n cubed is big O of n power 2 plus sin n. Is that true? Is that true? True means it should be always true. False? False means even for one example it is false means then automatically we say that it is false. Okay. If there is a counter example, is that true or not?
No, sir.
True? When does it become true? When does it become true?
N cube.
If n cube.
N cube it becomes true. But if sin n is minus 1, then it is false, no?
Yes, sir.
So that means now finally this statement is true or false?
False.
Even if there is one counter example, it is false now. So that's why it is false. Okay, false. Yeah, it is false. What about second one? What about second one?
False.
What about second one?
False.
should- it is again, it should be strictly. So it is again false now. What about third one? What about third one? What about the third one?
True.
Is it true or false?
Third one true, sir. It is true.
It is
True,
true
sir.
because it can go from n to n cube. Whatever value we get here, definitely it is going to be true, no? Why? Because this side big omega means this side it should be more. This is more, this is less. Hence, is it true or false? Is that true or false? Is that true or false? It is true. What about fourth one? What about fourth one?
False.
Fourth, okay, thank you. Okay. What about fourth one? Fourth one, is it true or
False.
false? It is false. Why it is false?
Because it should be
Maximum
strictly
value
less.
it can take is n cube. Even if we substitute here n cube, still it is wrong, no? Still it is wrong. Okay. Because values which are smaller than this, it is okay. But when it can become even n cubed also, that means when sin n is plus one, this doesn't hold. Is that okay? What about fifth one?
Plus Malay.
What about fifth one?
No.
What about fifth one?
It is false, sir. It should be equal actually. Order of growth should
Both should be equal. Here it may become n to n cubed anything. That means automatically it is false.
మా సార్ వచ్చాడు అమ్మకు చీర కావాలి అమ్మకు చీర
గూగుల్ పే చేయరా
Okay, please, all of you, okay, not
కార్ట్లో పెట్టరా కార్ట్లో పెట్టరా
I request all of you to please keep your microphone in mute. Okay, thank you.
Third one ఒకటే correct.
Okay, let us see this example. Here, one is log n power k, where k is greater than 1 is given, epsilon is greater than 0 is given, both are constants. Now, log n power k, one side we have log n power k, other side we have n power epsilon. Okay, out of these two, which one has higher order of growth? Which one has higher order of growth? This we discussed in yesterday's class. Which one has higher order of growth? Which one has higher order of growth?
Power epsilon.
N power epsilon, its order of growth is strictly higher, no? It is like this, no? Lower order of growth, this is higher order of growth. Lower order of growth, that example also we discussed. Now, one student has given an algorithm which runs in, say, log n whole power 9,999 time. Another student has given algorithm which runs in n power 0.01 time. Which algorithm is more efficient? Which is more
Log
efficient?
n 999.
Why? Because its order of growth is lower. Its order of growth is lower, smaller than the other one. So now you tell me, out of this, first one, is it true? First one, is it true? First one, is it true or not? This is clear. We know that.
Yes, it is true.
We know that. We know that it is holds. It is like this. Now, based on that, you should be able to tell me immediately everything, is it true or false? Is it true or false? First one.
True.
First one is true. Why? Because according to this, it should be less than or equal to. This is log n power k is less than or equal to this. What about second one? What
Also
about
true.
second one?
Also true.
Always this is this order we are following. Okay, now. equality. Okay, now this is big O, little o, big omega, little omega, theta. This is the relation. Okay. Now you please tell me now. Log n power k. Is this true or not?
It's true,
Yes,
sir.
sir.
It's true. What about third one?
False, sir.
Third
False.
one is false. Okay. Fourth one?
Also false, sir.
False.
Fourth one. What about fifth one?
Also false, sir.
Okay, is that correct? So any doubt at this point? Okay, now let us see this. N power k we have one side, other side c power n, where c is greater than 1. That is given. That is given. Okay. Now out of this, last class we discussed, now one student has given this type of algorithm, another student has given 1.001 whole power n time algorithm. Out of these two, which is faster? Which is faster?
2 power n.
Which is faster?
N power 999.
That is faster. That means which one has lower order of growth? Which one has lower order of growth? Which one has lower order of growth?
10 to the power 8.
This has lower order of growth, no? N power 9999 has lower order of growth. Lower order of growth. Now you tell me, what about first one? Is this true or not? First one is true or not?
Sir.
Yes, true.
Again, I'm
True.
writing your first one. Is it true or not?
Yeah, true, sir.
It is true. What about second one?
Also
True,
true,
sir.
Third one?
False.
False. Fourth one?
False.
Is that correct?
False. Yes, sir.
Is that correct? Okay. Now you please tell me here in this
So
case.
that's previous example, sir. There n is n raised to 999.
Okay. Okay. You have some doubt.
Bigger numbers.
Okay.
Yeah, this one.
Please tell me.
How this is low, sir? Why this left hand side is lower than right hand side?
So for that we need to understand formal definitions of asymptotic notations. So later we can show. Okay. I can give you the reason. We can show that limit n tends to infinite n power a by some constant c power n. This value is 0. We can prove this result. So that means if I take limit for large values of n, where a and c are constants, n power a by c power n equal to 0. This is the definition of which notation? This is definition of little o notation. Little o, this is small o. Okay, this anyhow we'll be discussing after some classes. Okay. So this holds. Limit n tends to infinite, n power a by c power n is 0. Okay, now this is the definition of little o notation. Hence, we can say that n power a equal to little o of c power n. So we will come to this after some classes. Okay, now first we try to completely understand these notations. Okay. After getting clarity on these notations, automatically these definitions you only will tell. Okay, oh, this definition should be like this, or definition should be like that. Okay. Otherwise, it will be confusing. That's why I don't want to introduce it at initial stage. Okay. Now, okay. Now here root n means n power 0.5. N power sin n means it can go from n power minus 1 to n power minus 1 to n power minus 1 to n power plus 1. Is that okay? N power minus 1 to n power plus 1. Is this correct? Why? Because sin n function range is minus 1 to plus 1. Minus 1 to plus 1. Is that okay? Now you please tell me whether first one is true or not.
Yes,
First one
sir.
is true or not.
False.
So it is false. What about second one?
False.
What about second one? This is also
False.
false. What? Third one?
False.
This is also false. Fourth one?
False. False.
Is there any doubt here?
No, sir.
Okay, let us go to another. Now let us see this. One side 2 power n, other side 2 power n by 2. Which has lower order of growth, or whether both have same order of growth or different order of growth?
Same order of growth, sir.
Same. That is it equal? Okay, let us see. So when does it become equal? If at all we are able to write to 2 power n by 2 as some constant into 2 power n, then both become equal, no? Okay. If 2 power n can be written as some constant into 2 power n, then both are equal. Both are equal. Now question is it possible or not? Is it possible or not? Is it possible or not? So 2 power n by 2, we can only write it as 2 power n whole power 1 by 2. Is that correct? We know that a power
Yes,
m
sir.
whole power n is a power m
A power
into.
mn.
Based on this, we can write it like this. Is that correct? Now
Yes, sir.
question is it possible to write it as 2 power n into something, into some constant? Is it possible to write it as 2 power n into some constant? Or in
sir.
simple
No, sir.
terms, if you want, even simpler way of doing this, one side it is 2 power n. So 2 power n by 2 we have. This I can write it as 2 power 1 by 2 whole power n. 2 power 1 by 2 whole power n. 2 power 1 by 2 means what?
1.
Square root of n. Square root of 2.
No, sir. It's 1 to the power n. Under root 2 to the power n.
What is square root of 2?
1.414, I think.
For something. Okay.
Yeah.
But maybe it's whole power n. Now I think at least based on this, we can easily say now.
Yes.
This is what it is. Actually, it is same
Lower
as
order.
1.4 something power n. Is that okay? N power n 1 by 2, both are not equal. Both are not equal. In fact, which is lower? This is like this. 2 power n, 2 power n by 2. 2 power n by 2 is strictly lower. Why? Because this is 2 power n, this is 1.4 something power n. Okay. Is there any doubt?
No, sir.
Okay. Now you please tell me, what about first one? Is that true?
False, sir. It is false.
Why? Because here always you remember it's this should be less than or equal to, less than equal to. Okay. It is false. What about
Yes.
second one?
Also false, sir.
Second one, it is also false. What about third one?
Third and fourth true.
Third one, is it true? Why?
Yes.
Because 2 power n is more than this, so it is true. Fourth one, this is also more than this, it is true. Fifth one, both are not equal, that's why it is false. Any doubt? Any doubt in this example?
No.
Okay.
N is equal to 0, both will be equal, right?
But we are doing it for only asymptotic, means as n tends to infinite only we are doing now, brother. As n tends to infinite, See, one important thing that we need to understand is we should not go by numerical value. That is the fundamental thing. Okay, we should not go by numerical value of that. We should not go by numerical value of that. If that is the case, for example, that's what we discussed now, 7n squared plus 8n plus 9. 7n squared plus 8n plus 9. Now 2 power n. If I simply take n equal to 2, n equal to 2, what is this value? Correct, no? Does it mean does it mean that it has a higher order of growth than 2 power n? No. That's what we learned yesterday's class. That's why we need to do it for as n tends to infinite. This finally becomes n squared. This finally becomes 2 power n. 2 power n. Is that okay? Okay. Okay. So now one side we have log n factorial. Other side we have log of n power n. So we know that log a power b is b log a. We know that log a power b is b log a. So what is log n factorial's order of growth? This we discussed in the previous class. What is its order of growth? What is its order of growth? N log n. Its order of growth is n log n. Log n factorial's order of growth is n log n. Is that correct? Remember, n factorial is approximately Stirling's approximation formula, root 2 pi n into n by e whole power n. After that, take logarithm both sides. Then we showed that it is n log n. No?
Yes, yes.
Okay. So log n factorial order of growth is n log n. What about this? This based on this formula, this can be written as this is also n log n. That means both have same order of growth. So that means finally this is like this, equal to log n factorial equals to log n power n. Now we tell me out of this which first one, is it right or wrong?
It's right, sir.
Second one
False.
is false, clear to everyone?
Yeah.
Okay. The third one?
True, sir.
Third one is true. Fourth one?
False, sir.
False. Fifth one?
True, sir.
Is it clear, or is there any doubt in this example? Is there any doubt?
Yes, sir.
Okay. Okay. Let us. Okay. Now let us see. Here C is a constant here. C is a constant. So what is given to us? N power log C. Other side C power log n. N power log C, C power log n. What can you say about order of growth of these two? Order of growth of these two?
C to the power log n is having higher growth.
But we know that A power log B base C is same as B power log A base C. These two we can interchange, still there is no change in the value.
Then equal.
Correct? So we know this property of this, no? So based on this, what is that we can conclude here? Both have same order of growth.
Same
Both
order.
have same order of growth. So because this is same, instead of giving this both are same, no? So hence, what about this? First one, is it true?
True. False. True again. False. True.
Is there any doubt? See, once you know what is the relation between the two functions. After that, only you need to remember definitions of asymptotic notations. That's all. Definitions of asymptotic notations. First, we need to decide which has lower, what is the order of growth. Okay. Now, you please tell me. One side we have n power log n, other side 2 power n. Other side 2 power n.
Again has lower order
A
of
can
growth.
be written as b power log a base b. Is this correct?
Yes, it is correct.
Yes, sir.
Okay. So now
Yes,
somehow
sir.
we ensure that okay, no, this one I'll write it something like this. Okay, no, this n log n, n power log n, we can write it as this entire thing. If we consider it as, say, it is a, then it can be written as some e, b equal to e. Okay, no, e power log n power log n base e. Is that correct? Is there any
Yes,
doubt
sir.
at this point? N power, because we know that a is same as b power log a base b. Is this correct? Is it clear why it is so? This can be written as a power log b base b, log b base b. Log b base b value is 1, a power 1, which means it is a. Okay. Hence, this entire quantity n power log n, we can easily write it as, e power log n power log n base e. Is that correct? Is that correct? Similarly, what about 2 power n? What about 2 power n? It can be written as, if I consider this entire thing as a, it can be written as e power log 2 power n base e. E power log 2 power n base e. Is that okay? Now, what is this value? This is same as n power log n. Log n I can take it outside now. Log n we can take it outside. So it becomes e power log n into log n into log n into
Log n.
log n base e. Log n base e. What about this? This can be written as similarly. N
E
comes
power
outside. E power
E
n into
log 2 power n base e.
no. N has come out.
Okay, sir. 2 base e.
Now, is it possible to compare? Is it possible to compare?
Yes, one end it is log n, other end it is n.
Even if we want to, we can consider this entire thing as log n whole square. This entire thing has only n. Log n whole square. This entire thing has even n. So now I think, are you able to make out which one is lower now?
Like e power n log 2 to the base e is lower.
That is it clear to everybody why it is smaller? Why it is smaller?
Sir,
Sir,
can
if
you
you
explain
don't
this
mind,
once more?
can you explain again, sir?
Okay. Let us see. So given directly n power log n and 2 power n, we are not able to compare directly. Okay. So we know that a is same as b power log a base b. Is this clear to everyone? Why is it so? B power log A base B. This is B and A we can interchange, we can interchange. So that's what I have done. A and B we have interchanged. Then what is that we have got? A power log B base B. What is log B base B? What is log B base B? It is 1.
1.
Okay. Hence A power 1, which is same as A. That's what I have written. A can be written as some new B power log whatever A we have taken. A base this B. Is that okay? Based on that, now what is given to us? N power log n is given to us. N power log n is given to us. So this entire thing we can say it as A. A. Okay. So now this can be written as B. Instead of B, I will take E. E power log E, and this n power log n as it is I can write now. Is that okay? Up to this we haven't done anything. We haven't done anything. Simply based on this relation we have rewritten it. That's all. Is there any doubt at this point?
No, sir.
Okay. And then we also know that log A power B is B log A. Okay. So based on that, this is of the form n power log n. No, this log n comes out. So it becomes E power log n has come out, and already log n base E is there. Is this okay? Is this okay? So therefore, n power log n is same as this. Similarly, 2 power n can be written as E power n into log 2 base E. Now you compare right hand side values instead of left hand side, right hand side values. Right hand side values. From that, is it possible to conclude easily? Is it possible to conclude easily? Is it possible to conclude? Okay, let me ask one more question. Log n into log n, I have one side. Other side, we have n. Which one has lower order of growth? Which one has lower order of growth?
Log n.
Which is same as, we can write it as log n whole square, log n into log n whole square. Other side, we have say n. Say n. So now tell me what is the relation between these two? Which one is lower? What is the relation between these two? Which one has a lower order of growth?
Log n.
That's what we discussed in our previous example. Log n whole power 9999, n power
Yes,
0.001, something like that. So from this, we know that it is strictly lower than n. It is strictly lower than n. Now bases are same in both. No, this base is E. Here also it is E. Here also it is E. Now you compare only top. Okay, no? Power. Log n into log n. Here it is n into log 2 base E. Out of this, which is smaller? Which is smaller? Which is smaller? Which is, see, bases are same. 3 power n, 3 power n, n by 3. Which is same, base are same. So n and n by 3, if we compare, that is enough, no? N and n by 3, if we compare, that is enough or not? So from this, easily we can say that it is more than this. Is that correct? Is that correct?
Yes.
Okay,
Yes.
so based on this, finally, which one has lower order of growth? Which one has lower order of growth?
Log n into log n. Log.
Log n into log e. Log e.
It is strictly lower than 2 power n. We know this result. Once the relation is known, these are the only simply easily we can say whether it is true or not. Now, please tell me, first one is true or not? First one is true or not?
True.
First one is true or not?
It's
Yes,
true.
sir. True.
What about second one?
True.
Third one?
False.
Fourth one?
False.
Is it okay? So what is that we have done? Directly we are not able to compare that. So we have written it in another form so that its basis we can are same, something is same, so that we are able to compare its power, and the power that we are able to decide easily which is more, which is less. Which is more, which is less. Okay, let us see this. 2 power n by 3. 2 power n by 3. Other side 1.5 volt power n. First, let us find the order of growth. Once we know order of growth, after this it is only matter of 1 second now. So here, in order to find 2 power n by 3, same logic which we used earlier, now you can use the same.
0.5
This can be written
power
as
n
n
squared.
power 1 by 3 whole power n. Sorry, 2 power 1 by 3 whole power n. What is 2 power 1 by 3 means? Cube root of 2, no? Whole power n. What is cube root of 2? What is cube root of 2?
1.25.
Thank you, sir. 1.259 whole power n. This side 1.5 whole power n. Now it is direct, no? So which has lower? Which has lower order of growth? Like this. 2 power n by 3 has lower order of growth than 1.5 power n. It is 2 power n by 3 only. Is that okay? Is that correct?
Yes, correct.
Now you please tell me immediate answers. Even we should not take even a second to answer. After deciding this, it should be straightforward. Okay.
True, true, false, false.
So first one, what about first one? This is smaller, no? This is smaller. That means is it true? Yes. What about second one?
True.
True. Third one,
False.
is that okay?
Yes.
Okay. So now let us see. Instead of values, they have given in terms of functions now. Okay, no? It is given in terms of functions. So f of n and g of n be asymptotically positive functions. That means f of n is greater than 0. G of n is also greater than 0. This much is given. Now, what is first condition? It is given here. What is the first condition? F of n is big O of f of n square now. F of n square. Is this true or not is the question now.
Asymptotically, it is true.
Because asymptotically, whatever we are doing, everything is asymptotically only. Okay. Is it true or not? We should be very, very careful while answering this type of questions. F of n and g of n be asymptotically positive functions. This much is known.
It's true.
They haven't said anything more than this. They simply said they are asymptotically positive functions. That means if I take, say, for example, n square, f of n is n square, then it is clear that n square is
Always positive.
big O of n square.
10 to the power 4.
Okay. That means is it true? It is true.
Yes, yes, it is true.
This example, it is true. I am not saying whether that statement is true or not. We don't know. This example 1, it is true. Example 1, it is true. And we are almost tempted to say that it is true. Why? Because whatever we take, no, 3,
If
even
0.5 means we may
even
false.
2 power n if we take, it becomes big O of 2 power n whole square. Still it is true. Okay. But if I take f of n as 1 by n, f of n as 1 by n,
then it will be false, sir. It can't hold the relation.
so then what happens?
Statement is false.
Because this 1 by n is greater than 1 by n square, no?
Yes, sir.
Sir, one thing is we consider f of n as an operation count. So how
No.
operation count can be one by n?
See, so here whatever problems they give, they every time they need not be based on simply after giving algorithm, they might not ask. Just like this, if they ask, then we should be able to answer, no, those type of questions also.
Okay, understand.
Here our intention is not only learning this and get a competitive exam point of view, what type of questions they ask, that questions we should be able to answer correctly.
Yeah, but at the same time, being a computer science student, I must aware that 1 by n is not practically true in case of analysis of algorithm.
But according to the definitions of asymptotic notations, it works. No, it is correct. No.
Yeah, it works. Yeah, it works. Fine.
Here we need to cover both that side also, even this side also. Okay.
Yeah.
Okay. So what about this finally? What is the answer here?
It falls in this case.
What about even one counter example?
Omega. Yeah, in that case, it is omega.
Okay. Even one counter example, if we find, that is enough. One counter example, if find, that is enough. What about second one? F of n is big O of g of n, which implies g of n is big omega of f of n.
I feel it is true.
Yeah, because equality is there in big omega and big O also.
If here it is
no.
It is g of n, this side it is f of n.
Oh, no, it's not true, sir. Sorry. That is how opposite that is. The functions are same, it is true. If these functions are different, it is
but question is this. Okay, now we need to answer for this. Okay. So one counter example, if we can find, then we can say that statement is false. Okay. Because simply by knowing that, seeing one example where it is true, based on that we cannot conclude. One wrong example, we can conclude that it is false. Based on one correct example, we cannot generalize it. Okay. F of n is big O of g of n. That means what? F of n's order of growth is less than or equal to g of n. This is order of growth point of view. Order of growth of g of n. Now what is that they are saying? If it is given, does it imply that g of n, order of growth of g of n is greater than or equal to order of growth of f of n? Is that true or not?
So I don't find any example where it is false.
Because if we are not able to find one or two examples after trying, if you are not able to find, simply go see the definition. What it is, we don't require example in this case. Why? Because here, what does it say? Order of growth of f of n is less than or equal to order of growth of g of n. The other side also, what is that it is saying? G of n's order of growth is greater than or equal to f of n's order of growth. Both are saying essentially the same thing, no?
Yes.
So that means easily we can say that it is true.
Yes.
Is there any counter example? I don't think there is any counter example in this case. Why? Because it is straightforward. It is straightforward. It is. Okay. What about third one? F of n is theta of f of n by 2. F of n by 2. For example, if I take f of n as n square, what is f of n by 2?
It is the
N by
1 by
2
2 whole square.
N square by 4.
So
Both,
that is
is it
also
satisfying? Is it
yes, sir.
satisfying? Based on this, can you conclude that yes, it is correct? Yes, it is
It
correct.
is correct. Yeah. Yeah.
No,
It is correct.
no. For this example, it is true. But
True, but
we need
all
to
examples is not.
we need to convince ourselves that there are no examples where it fails. Okay, so that is important. One example, it is false means automatically we can conclude that it is false. One example, it is true means based on that you cannot conclude that it is the entire statement is true. The entire statement is true. Is that okay? Now, what is that? What is the answer that you believe here? Is it true or false?
We can take 2 power n as counter example, sir.
Thank you very much, brother. Okay. So if we take 2 power n, f of n is 2 power n. For example, if we take f of n as 2 power n, then what is f of n by 2? 2 power n by 2.
2 power n by 2.
2 power n by 2 means square root of n.
Square
2
root of
power
n.
n. It is 1.4 something power n.
Yes, sir.
In this case, whether both have same order of growth?
No.
No,
No,
different. Different. That means whether this third statement is a true or false?
False.
Is that okay? See, because this example it is true, based on that we should not be tempted to say that it is true. Okay. Say for example, all students in say some XYZ, all computer science students, 4th BTech computer science students in XYZ College of Engineering are placed. Okay, no, XYZ College of Engineering are placed. When does that statement become false? When does that statement become false? Even if there is one student in BTech CSE who has not got any placement, who is not placed, then the statement becomes false or not? The statement becomes false or not?
False.
But if I find one student or 2 students or 10 students in that 4th BTech CSE who are placed, does it imply that the statement is true?
No.
No, it should be true for each and every student in that class. It should be true for each and every student in that class. Then only the statement is true. Is that clear? Okay. False is easy, but counter example, coming up with counter example is very difficult actually. Okay. So finally it is false. Now what about 4th one?
It looks like true only.
F of n plus f of n, that means we know that order of growth is, this entire order of growth is how much? Please tell me. What is?
If f of n I take n square.
It is less than fn. Here it is exactly fn. Overall, this entire order of growth is f of n only.
F of n only.
F of n only. Thank you, sir. Okay. F of n only. So this side it is f of n. It's what is its order of it is f of n. That means is it true or false? Is it true or false? It is true. It is true.
Actually, it is look like true only. Why? Because both side f of n.
That we don't even, we need not even think much in this case. Why? Because
yes,
first f of n is there. By seeing that, easily we can say.
Yes.
Easily we can say. Okay, let us. Okay. Now say here we are given 8 functions. 8 functions. We are given 8 functions. We need to arrange these functions according to order of growth. According to order of growth. That means which order we need to do this? What is the order we need to follow here?
Order of growth.
Increasing order of their growth.
Is it increasing order or decreasing order? So we need to give order G1, G2, G3, and so on, say G8. G1. Now out of this, G1 is highest or G8 is highest? Which one is lowest and which one is highest?
Order of rate of growth of G1 must be highest and G8 must be lowest.
So G1 it should be greater than or equal to G2. G2 should be greater than or equal to G3. G3 should be greater than or equal to G4. And this one G7 should be greater than or equal to G8. Now you tell me out of this which is highest, which is lowest, which is highest. What in our ordering? First we should write the smallest one first or largest one first?
Largest one first, and we need to reach to the lowest one. Right?
That is, we need to give order where it is largest, highest order of growth, highest order of growth. This side it is lowest order of growth, lowest order of growth. Okay, so that is the order in which we need to write. That is the meaning. No, G1 is big omega of G2 means what does it mean? This side it should be greater than or equal to G2. That means G1 is more than G2, more than or equal to G2. Is it clear to everyone? Highest to lowest order, we need to rewrite the functions. Is that clear? Is there any doubt?
So
Clear, sir.
Okay. Now we will first look at the functions. Out of this, which function? What is this order of growth is very clear. It is 3 power n only. What is order of growth of this? This also we cannot simplify further. Let it be like this. What about this? I think we can do something about it. What is its order of growth? N power 4 into log n factorial. What is its order of growth? What is its log n factorial's order of growth is how much?
10 to the power n.
N log n.
N log n. It is
It's n log.
Order of growth. It is n log n. N log n. That means this entire order of growth is n power 5 times log n. Is that okay? Now let us look at this. What is this? NC n minus 5. NC n minus 5. We know that NCR is same as NC n minus R. We know this, no? NCR is same as NC n minus R. Is that correct? NCR is same as NC n minus R.
Yes.
5C2 is same as 5C3, no? 3 is 5 minus 2. Okay, so based on this we can write it as easily NC n minus 5 n minus 5. Is that okay?
Yes.
Is that okay? Now, which is nothing but NC5. What is NCR formula? All of us know what is NCR, no?
N factorial divided
So
by 3.
NCR is factorial n by n minus r
factorial into n minus r factorial.
N minus r factorial into r factorial. Is that okay? So based on that, NC5 can be written as n factorial by n minus 5 factorial into 5 factorial. Okay. Again, this n factorial can be written as n into
n log n.
n minus 1, n minus 2, n minus 3, n minus 4 into n minus 5 factorial. Is this correct?
Yes.
N factorial, is it correct? N factorial is n into n minus 1, n minus 2, n minus 3, n minus 4 into n minus 5 factorial. Is that correct or not?
Yes, correct.
So now what is the value we get in place of n factorial if I substitute this? What is that we get? What is that we get? Let us write here.
n to the power 6.
No.
n into
What
n
of
minus
n to the
1
power 6?
N into n minus 1 into n
minus
minus 2, n minus 3, n minus 4 divided by 5 factorial. Correct? No, n minus 5 gets cancelled. No.
Yes, sir.
Okay. So now, okay, this n into n minus 1, n minus 2, n minus 3, n minus 4, if we simplify, what is the highest order term in this? Can
n to the power 5.
N power 5.
Yes.
Is it clear? N into n minus 1, n minus 2, n minus 3, n minus 4, highest order term is n power 5. Is there any doubt in that? Okay. So that means it is highest order term is n power 5, and it is what is the coefficient of highest order term? 1 by 5 factorial. 1 by 5 factorial. Any by 1 by 5 factorial, it is a constant we neglect. So finally, what is its order of growth? Order of growth is
n to the power of 5.
N power 5. So finally, this entire thing is same as n power 5 only, no? Okay. N power 5. What about this? Okay, this we need not even simplify. So this I think we can give it a try. What is this value?
Which one?
Root n to the power 3.
What is root n?
Root n to the power 3, because log 2.
8 base 2 means easily we can write it as root n power 3.
Yeah.
This
Power
again
3
we
by
can
2.
change it as
N power 3 by 2.
n power 1 by 2. Root means
Means
1 by 2,
3 by 2.
Power 3 by 2. N power 3 by 2 means this also.
1.5.
Finally, it is only n power 1.5. Is that okay?
Yes.
So we know that it is n power 1.5. And this is 0.6, no problem. This is also 0.64 n, no problem. Now you look at all, and okay, we will start from lowest. Okay, lowest. Out of this, which is lowest? Which is lowest? Definitely n power 5 is not, 3 power n is not lowest, n power n log n also not lowest. Why? Because there is something smaller, n power 5. Here also n power 4, this is also not lowest. Why? Because n power, okay. What about this? What about this? This is n power 1.5. This is n power 1.1 log n whole power 20. Out of this, which is smaller? Which is smaller?
Log n whole power 20.
That is why, because this n power 1.5, we can write it as n power 1.1 into n power 0.4. Is that correct? N power 1.5 can be written as
Yes,
n
sir.
power 1.1 into n power 0.4. Now, if we compare both n power 1.1, n power 1.1, neglect it. Now, remaining, what is that? One side we have log n whole power 20. Other side we have n power 0.4. Out of this, which is smaller? Which is smaller? One side log n whole power 20. Other side n power 0.4. Which is smaller?
Log whole power 20.
Oh, sorry, n I forgot to.
Power 1.1 is there, sir.
Madam, That's what, madam. Here also n power 1.5, 1 power 1.1 is there, no? This n
yes,
power
yes.
1.1, that n power 1.1, I am not even considering. Both are same, no need, no point, no?
Okay.
That's why one side log n power 20 is there, other side n power 0.4 is there. N power 0.4 is there. Okay. Out of this, which is smaller? Similar examples we have already discussed.
Left hand side is smaller.
Left hand side, thank you. This is smaller. Now, out of these two, which is overall, which is smaller? N power 1.5 is smaller, or n power 1.1 into log n whole power 20?
N power 1.1
log n whole power 20 is smaller than this. Yes, sir. Okay. Again, we come to that. But if we look at here, n power 1.1 is there, n power 0.6 also is there. No. That means this is not smallest. This is not smallest. Okay. This is not smallest. So that means up to this is smallest, no? N power 0.6. Is that correct?
Sir. Yes, sir.
Now, what about 0.64 whole power n? It is exponential form.
That is
It
highest.
will be greater than n power 6.0, 0.64.
0.64 whole power n. What can you say? What can we say about its order of growth? Is it more than
Definitely higher, sir.
0.6 or less?
Sir, it is highest exponential function, I think.
No, but it is 0.64. It's less than 1, so it will go on reducing.
That example also we discussed now in the previous class.
Yes.
Base is between 0 and 1. It converges to 0.
Lower order, yeah.
It converges to 0. The value gets reduced, no? Or we can say that
reduce.
n becomes 0. Sorry, it converges to 1. It converges to power is 0, so it is converges to 1.
Now here power is not 0, no, sir.
No.
0.64 whole power n.
To 0. I am talking about this one, no? 0.64. As we keep on multiplying, as n tends to infinity, it converges to 0.
Yeah. So it's lower order, no? Yeah.
Is it 0.64 into 0.64? We will get 0.3 something, no? It converges to 0. Sorry, not 1. Okay? 0. Now, from this, can you please tell me which is smallest? Which is smallest?
0.64.
That is okay. Now I am going to put order. Okay, that is this is smallest. This is smallest. So G8. Can we say that this is G8?
Yes.
G8. Okay. Now you tell me what is G7? What is G7? What is G7? Now we have order of growth of all functions here. Which is G7?
N power 0. Okay. Next, you
which smallest
we is left to simplified, second one, n to the power log n log n. It is left to be simplified, no?
It is very much clear that log of this is n power 0.6. It is n power log of log n. We can choose n value such that log of log n is more than 0.6, no, easily.
Yes.
Because this is constant, this value can change. If I choose a value where log of log n is more than 0.6, then this is more than this. Similarly, if I choose a value where log of log n is more than 5, it will be more than n power 5. If I choose a value n where log of log n is 20, then it will be more than n power 20 also.
So G7 is
G2.
G7 is n power 1.1 log n whole power 20, sir.
But now you compare, n power 1.1 is here, n power 0.6. Out of these two, which is smaller? N power 1.1 log n 20, n power 0.6. Which is smaller?
That is G5 is smaller, sir.
No. My question is, out of these two, out of
So now next we can write n to the power 0.6. That is right.
Out of these two, which is more? N power 1.1 into something is more, or n power 0.6 is more?
N power 0.6 is more.
No, here it is n power 1.1. No, 1.1 is more than 0.6. No, sir.
Yeah, so G7 is n to the power 0.6.
This is n power 1.1. This is 0.6. Automatically 1.1 is more than 0.6. No.
Yes, sir. Yes, sir.
So now you please tell me, among all this, which is least, next list. G8 is over. Forget about G8. Now remaining
power 0.6.
N power 0.6.
Is there any doubt? This is our G7. Any doubt?
No.
Now tell me what is G6, next highest. In the remaining, which is lowest? Remaining 6, which is lowest? Remaining 6, which is lowest?
N power 0.6.
N to the power 5, the NCR one.
This is n power 5. See,
Yeah,
n6
N
minus 5
5, N
is
power
n
5.
power 5. But n power 1.1 into log n 20. So n power 5 and n power 1.1, if we compare, I think.
But n to the power 1.1 multiply by log n to the power 20 is also there, na, which equivalents to n to the power 0.4.
No, that's what. Log n power 20 is less than n power 0.4. No, not only that, log n power 20 is already we discussed is less than n power 0.00001 also. No, we have already seen log n power k is always strictly lower than n power epsilon for any epsilon greater than 0.
Yeah.
So it is of.
So this is G6. Yeah.
N power of.
Madam, tell me.
N power of log 2 power 8 is there, no, sir?
That is 1.5. This is n point 1.1.
This we have already simplified, no, madam. This is finally n power 1.5.
N power. Okay.
So now you tell me which two things you have in mind, at least based on that.
Now then here, sir, the lowest compared to G5 and G6, now n power 1.1 log n power 20 is the smallest.
N power 1.1. See, so after removing these two, in the remaining functions, which is lowest is this one only. Is there any doubt?
Yeah, that is n power 1.1 log n base log n power 20.
That's what that is G6 now. Next lowest.
Yes.
Okay. After this, next one. Next one, I think we should be able to say very easily.
Next one is 1.5.
Next one is 1.5. This should be G5. Next one.
N power 1.5. It is a G5.
Okay. Next one. Which one is G4? So, because order of growth is here. See, this is n power 5. This is n power 5 into log n. Log n is there, means definitely it is not the one. Next list. This is n power log of log n. I have already mentioned log of log n. We can choose any large value so that it is more than n power 5, more than n power 20 also. Next lowest is
n power 4 log n factorial. What is that value?
That becomes n power 5 into log n. N power 5 into log n. So next lowest is n power 5. Any doubt at this point?
N power 5. That is, yes, sir.
Next lowest.
3 power
Next
8.
lowest. This is n power 5 into log n. This is n power log of log n.
N power
Which is
log
smaller
of
out of these two?
N power 5 log n.
This is very much small when compared with this. So this becomes our G3. Is clear?
N power 5 log n.
Okay. What next one? 3 power n and n power log of log n. Which one is smaller? We have already seen 2 power n into n power log n. This relation we know, no? 2 power n and n power log n we know. We have, I think, this class we discussed. We know that 2 power n is very much high when compared with n power log n, no? So now out of these two, which is smaller? It is n power log of log n. It is even smaller than
3 power n.
Log n, no? It is smaller than n power. So n power log of log n is very much smaller than n power log n. We know that n power log n is smaller than 2 power n. 2 power n is smaller than 3 power n. So finally 3 power n and n power log of log n, what is the relation? 3 power n and n power log of log n, what is the relation? 3 power n is very much high when compared with n power log of log n. So that means this is G2.
And then G1. Okay.
This is remaining is G1.
We need a lot more experience. We need.
This only definitely
practice, need
we
practice,
need practice.
because
need practice, sir. Yes.
Okay, I stop here. Okay, we'll assemble again. Okay, at 6:30. Okay, thank you.
Yes, sir. Thank you.
Yes, sir.
Madam?
You are from